Welcome students. Today we are going to discuss about frequency response of BJT, which is in unit 3, frequency response of BJT and MOSFET. It is the first of your unit 3. Initially, the frequency response has to be drawn using semi-log scale. Meaning is off axis will be in the log scale and the remaining off axis will be in the linear scale. So that's why it is called as a semi-log graph. In your x-axis, it will be in the semi-log, that is your log scale, and it is of frequency, its unit is hertz. And in y-axis, it will be a normal linear scale and its measurement is gain, unit is decibel. And it has three regions. So the curve will be like this. The first half will be the low, followed by mid frequency region, and followed by the high frequency region. The maximum point is called your A max. From that, you have to reduce the 3 decibel because of finding the cutoff frequency. It will be the A max by root 2. 1 by root 2 value is 0.707. So that's why if you convert into a log, it will become the minus 3 dB. And we have the graph and your A max by root 2. Wherever it intersects, that point is called your FL. The same way in right hand side, wherever your line and your graph is intersect, it is called as a FH. So FL stands for lower cutoff frequency, FH stands for higher cutoff frequency. Difference between these two will gives you the bandwidth. The low frequency region is Fs less than FL, and mid frequency region is FL to FH portion, we call it as a mid frequency, and high frequency region it is called Fs greater than FH. And then have to transistor amplifier with circuit capacitors. So capacitor plays an important role while in BJT as well as the MOSFET. In a BJT, the surroundings we are having the different types of the capacitors. In general, the classification we classified into external type as well as the internal type. The external type resist capacitors always will be the high in the range of 10 to the power of minus 6. And internal capacitors will be always the low and it will be in the range of 10 to the power of minus 9 and minus 12, nano and pico. The external capacitors is classified into two things, coupling and bypass. Coupling gives the input and output direct relationship, and bypass will eliminate the negative feedback biasing. Thereby, your gain has to be increasing. Eliminate the negative feedback biasing. Then diffusion, it will be in the forward bias junction we have to insert. Transition capacitor, otherwise called as a junction capacitor, and it is working in reverse bias junction. Reverse bias in the sense it is called collector to base, and forward bias means emitter to base junction. So this transistor is called transition capacitance. So from emitter, so this is your base, collector as well as emitter. Base to emitter, it is called as a forward bias region, and this capacitor is called as a diffusion capacitance. And this coupling capacitor provides a direct link between your Vi and your V0, that is input-output relationship. The bypass capacitor, if it eliminates if you introduce a bypass capacitor in the emitter terminal, it will eliminate the negative feedback biasing into the BJTs. Thereby, your gain has to be increasing. It is not further reducing. So this is about the introduction of the frequency response of BJT as well as that transistor amplifiers with circuit capacitors. Thank you, students.